Hey everyone, welcome to the tutorial for deploying your own ERC20 tokens on the Gnosis chain. In this tutorial, we might uh, deploy it on the GRDO testnet or the Gnosis main chain itself. So let's start with it. So first of all, let's open the terminal and download Foundry up. We'll be using Foundry for this tutorial, not Hard Hat, because Foundry is the more dominant choice for developers these days. So, right, this is the Foundry book, and you'll see that to install Foundry, you'll have to first go and write this instruction on your terminal. So I could write this here and hit enter, but I've already downloaded Foundry. I mean, Foundry up, and Foundry up installs Forge. So I won't do this. I'll directly jump to the next step, which is testing whether Forge has been installed into your system or not. How we do that is we check the version of Forge and it's 0.2.0. That means that we do have Forge installed. And also, one point to note here is that this two instructions should be enough to uh, help Foundry getting up and running in your system. But if it is not enough for you, if you encounter some problem, then you can always build from source using this command, and then it will install Foundry up, which you can use to install Foundry, Cast, and Anvil. Right. So let's see what's the next step here. We've checked the version, it's installed. Okay, now we have to set up the folder. Now let's go to our desktop, create like demo project folder, go into the demo project folder and do Forge init. This will initialize a new Forge project inside of the demo project folder. Now we open that particular folder, and now we see that this is the kind of file structure that we have been presented here, right? So you can see that there is this particular source folder which contains the contracts that we'll be using. So let's create a file here called token.sol, which will contain the code for our tokens. And let's see what's the next instruction. The next instruction is to next instruction is to first of all import the dependency, which we can do right now by copying this, going back. Now this is the command to install the OpenZeppelin dependency. So what this command will do is that it will import all the contracts from the OpenZeppelin repository on GitHub, which is essentially the most followed and most reputed library for the widely used smart contracts. And let's install it. Let's see if it gets installed or not. Cool. So we installed it. Now, just as a dry run, we'll see whether the existing contracts are getting built or not. Forge build, fine. And whether the existing tests are working or not. Again, the tests are getting passed, so this is all good. Now we'll go ahead and copy this particular set of instructions in our token.sol file and save it. So what this contract does is basically imports the OpenZeppelin contract and from there it takes the ERC20 contract and imports it into our token.sol. We inherit that ERC20 contract into our test token. That is what is meant by test token is ERC20. And then we create a constructor where we name our tokens test token Gnosis or TTG, and we mint 1,000 tokens of 18 decimals each to the message.sender. Message.sender would be the person who deploys this particular contract, so that would most probably be us. And also you can name your tokens whatever you like because it is your token after all. So let's get ahead and see what's the next instruction for us. Okay, so let's check again whether Forge build is working or not. Forge build after passing our new token contract is working. Cool. Now preparing to deploy our token contract, right? So to deploy our new token contract, we will need to pay gas fees to the people who maintain the blockchain. These people are called miners or node operators, right? And to give this particular fees to them, we need to have a wallet. And that wallet would be used to deploy our contract and later interact with it too, right? So I will be using a wallet called MetaMask. You can use any wallet that you like. This is the one, and you can download for Chrome. Since I've already have it downloaded, I'll show you just simply by creating a new account and not really going for a new wallet itself. I'll name this as demo wallet, create, and awesome. Let's, for example, forget the Giardo and Gnosis chains from our wallet. So yeah, now what's the next instruction? Gas fee, later interact with, choosing wallet. Okay, cool. So now it is written that from the official Gnosis wiki, we have to put the Gnosis chain into our MetaMask wallet. The MetaMask wallet inherently or by default works only for the Ethereum chain and its testnets, but we also want it to work for our Gnosis chain and its testnet GR2. So what we'll do is we'll go to this particular official wiki. This will open up this website. And what we'll do here is that we'll go for manual configuration. You can always go for this thing, deep link. This will automatically do it, but I like to do it manually because it helps me see what I'm actually doing, right? So let's see what it's saying. It is saying to open MetaMask, fill it custom RPC from the network top down, and use these details in order to create the GR2 testnet, right? You can also, make it compatible with the Gnosis mainnet by using these details. But let's go ahead with GR2 testnet and include these details. Now I want to add this new chain, which is the GR2 testnet. I go to add network. This will open up this new tab, and I'll simply import the details from the official page. So the network name is GR2. We put the network name here. The RPC URL is rpc.gr2chain.net. We paste it here. The chain ID is 110,200. We paste it here. The currency is, I think, GR2 XDAI. We paste it here. And what is the block explorer URL, which is blockscout.gr2chain.net. We put it here and we save this, right? So you can see now our wallet is compatible with the GR2 testnet, which is cool, right? So we can basically use our wallet now to interact with the GR2 testnet. And also, what is testnet and what is mainnet? You can read it from the tutorial itself, but I'd like to give you a very brief idea. A blockchain is a chain of blocks where real apps work and where real transaction of money happens. And the testnet is a mock blockchain where you can use mock money to pay to the node operators, and it is basically to test how your apps will work in the mainnet, right? So cool. Now we have a wallet, so we can pay our gas fee, but we have zero Chia DAO X DAI. How are we supposed to pay gas fee, right? So Gnosis very generously provides us with a faucet that we can use to get some X DAI. So let's copy the address from here, go to the Gnosis X DAI faucet. I had already taken some testnet DAI today itself, so I think they won't let me take more. Oh yeah, they let me take me, right. So cool. So XDAI has been sent to my wallet, and this is the transaction hash. So let's check whether we did get our GR do XDAI or not. Yeah, we got it. See, pretty fast for a blockchain, right? So yeah, now we have one GR2 XDAI. Now we can definitely use this money, this mock money, to pay the node operators or the miners of the testnet, right? So let's go and see what's the next step. The next step is deploying our smart contract, right? So let's again forge build and see if there is no issue with our contract build. So no changes were made, so therefore the compilation was a success. Now we need to grab the private keys of our MetaMask wallet, deploying address basically. And a note about private keys. Private keys are meant to be private, it is not to be shared. And just for this particular tutorial, I will be exposing my private keys. And this is a throwaway wallet. I do not use it, so it doesn't matter to me if you can see my private key or not. But make sure that your private key of the wallet that you use are never exposed, are never saved in places where it can be seen by other people, right? So how do we get the access to a private key? We go to MetaMask. We see whether we are on the correct wallet address or not. I mean, there are multiple accounts, right? So let's see whether we are on the correct wallet address or not. We are. Let's go and see the account details, and then we can go to export private key, and then we type our MetaMask password, which is super complex. It should be super complex, and confirm. Cool. So now we get our private keys here. We copy them and we paste them somewhere here. This is a very bad practice. Do not do this ever, but just for the sake of this particular tutorial, I'm pasting it here, right? You have to use this particular key and save it at a very safe place. Cool. So now that we have a private key, we'll see how we can deploy it. So we have two options. We can either deploy it on the GR2 testnet or the Gnosis mainnet. Since I only took the faucet funds for the testnet, I'll be going ahead with the testnet deployment. So the testnet deployment command looks something like this. We'll copy this and paste it here and make changes to it so that it is correct. Okay, right. RPC URL is this, private key is this thing here. And what is our source slash file name? File name is token.sol, and our contract name is, you can see here, it's test token, right? So we'll go ahead and write test token So this is the overall command that we will use to deploy our smart contract to the Giado mainnet. I mean Giado testnet. Let's do forge build once more to see if there is no more issues. Cool. Now we paste this and hope that it gets deployed to the testnet without any issues. Let's wait and see. Oh, nice. Very fast, huh? Today it's very fast. Cool. So you can see that the deployer is 0x59b16, which is our wallet address, as you can see here. 0x59b67076707, right? And it has been deployed to this address, right? So this means the address of your token contract is 0xCEE222800F and all, right? So basically your token contract address is this, your token address is this thing. That's it. And the transaction health for this transaction is given here. So now what we'll do is we'll see what's the next step in the tutorial. Right. Congratulations, you just deployed your token. Right. Okay. Now let's go and see in the Chiado Explorer whether our transaction was successful or not. So let's go to our wallet, copy our address, put it here and search, right? So it shows that a minute ago, a contract creation was successful and this particular address, which is our wallet address, created the test token, Gnosis tokens, which is of the address 0xCE22228 and 9F everything, which you can see is here, correct, right? So this is cool. Again, you will wonder that, hey, I deployed my own tokens, it's visible on the terminal, it's visible on the Block Scout Explorer, but why is it not visible on my wallet, right? It should be in my wallet because I was the message.sender, I created the contract. I should be getting those 1,000 tokens of 18 decimals, right? So where it is? So the thing is that MetaMask could not detect all the tokens automatically. So what you have to do is go ahead, copy the contract address and import it within your wallet. Don't see your token, import tokens. Token contract address, we just paste it and the token symbol is auto-populated, the token decimal is auto-populated and we add custom tokens. And you see, we get 1,000 TTG tokens, which is test token Gnosis. We import tokens and we are good to go. You can see 1,000 TTG. Also, you can see that we had one GR2 XT, but it has been reduced to 0.9982 GR2 XT. Where did that difference go? It went to the miners, to the node operators as the gas fee for letting us deploy our smart contract on the blockchain, right? That is known as the gas fee. Cool. Now let's see what's the next step in our tutorial. Add custom token. Yeah, it's done. You can see your tokens. That is fine. Okay, now let's connect our this particular contract to a front end, right? We are going to develop a full stack front end, full stack dApp. dApp is a decentralized application. So let's go ahead and create a new folder, which is a React application, right? So let's cd dot dot and make a new folder, React project, npx create React. Oh, got a bit too excited. Create React app. What should we name it? ERC20 front end demo, right? So this will create a React app. This will take some time. So let's wait for the React app to get completed. Why React? Because React is the most widely used front end framework in the crypto space. Although I think there are better front end applications, front end frameworks out there, but since React is the most widely used, it has the most infrastructure and tooling around it. So we'll go ahead with React. So you can see that we have probably, okay, it's still running. Cool. You can see that we have installed our React app. Now what we should do is install, first of all, go into our folder that we just created, ERC20 front end demo, right? And here we will install a new package called ethers.js. Ethers is a library which will help you to communicate your front end. Communicate to the smart contract from your front end, right? It will be like as a link between your front end and your smart contract. So the command to install that is npm install save ethers. I think I should already have it installed. Okay, cool. It was not, right? So yeah, we installed it, and now just to see whether things have installed correctly or not, we'll do npm run start, and this should open the default React app. Yes, so the default React app opens up. That means that everything is working smoothly. Now what we have to do is go and make changes to source/app.js as this default app is suggesting. Now what changes do we exactly need to make? It's written in the tutorial itself. Right, we copied this piece of code and put it in source/app.js. We close this particular thing, and we also close this particular thing, and we open our code editor, and inside of this we go to app.js and we remove this and use the code copied from here. Now you'll see that we are importing token from contract/test token.json, right? But there is no contracts folder here, right? So let's create a contracts folder. Let's create a test token.json, and now we need to put something here, right? What do we need to put here? So we need to put the ABI of the contract that we have written, right? An ABI is an application binary interface, probably, I think. Yeah. So an application binary interface basically tells other software, other programs how to interact with your particular smart contract, right? So where do you think this ABI should be right now? Hmm? Right. The folder where we created our smart contract and compiled it, there should be a file, there should be an output which should have the ABI of our token contract, test token contract. So let's go ahead and see where it is. cd demo project, open it up. Now we'll see that there is this particular contract that we wrote. Now to find the ABI, we go to out, we go to token.sol, we go to test token, right? And here this is the ABI. So this ABI essentially tells every other software how to interact with the software, our contract basically. So we copy this, we close this, and we go back to this particular test token.json and paste it right here, right? So now, as you'll see that we have certain functions, get balance and send coins. Get balance should help you get your balance, and send coins should help you to be able to send your particular tokens to some other address, right? So let's see how this is working. Okay, cd back, cderc20, front end demo, npm run start. Cool. So this is our new front end, not very fancy. So now we are on this our very fancy front end. So what you'll notice in the front end code here is that where is our front end code? Yeah, here we have declared const token address as this particular address, right? So this is some other token address. This is not our address, right? So let's go ahead and see what was our token address. It was 0xCE2222. Let's copy that and put it in our code right here. Save it. And let's get back to our React app. Right. So now when you click on get balance, you should get the balance of 0x59b 160d is 1000. So what is this is saying is essentially that this particular wallet has 1000 balance of TTG, test token Gnosis. This is good, right? So let's assume that we want to send 50 tokens to someone else. So suppose I want to send 50 tokens to this particular address, 0xabd something, and let's see how do we do that. So we paste the address here, we enter amount 50 and we do send coins. We approve the transaction and then we wait for a bit for the coins to go through to the other address, 0xabd address. And once that is done, we should see our transaction successful message. Hopefully, we never know what happens. Cool. So you see the transfer was successful and the balance of our wallet has been reduced by 950, right? And if you see in the token wallet itself, our balance has reduced by 50 and it has reached 950. And also in activity, you'll see that we have sent TTG to this particular address and it has been minus 50 TTG, right? So this was the end of tutorial. You are very welcome to explore more about ERC20 tokens. And if you want to see how we are able to send the particular tokens, get the balance and things like that, simply go to this particular, where should I say? Simply go to the project, the folder where you deployed your contracts, open it, and there you should be able to see this lib folder, and inside of this lib folder you will see open Zeppelin contracts, and in this open Zeppelin contracts you'll again go inside contracts, and inside of these contracts you'll again see what token. So let's go to token, right, and we go for ERC20 and you see ERC20.sol. So this particular contract explains what is happening, right? And this is the 18 decimal that is by default. We can change it, of course. This can be an exercise for the future. This return symbol and a lot of other things. So yeah, you are free to explore more and write more custom contracts and definitely design better front ends. Thank you.